NumPy and Pandas. Today we're going to cover these both very quickly and simply for a general overview of both. Let's get right into it. NumPy is a Python library used for working with arrays. Now arrays are containers of information. NumPy arrays are much faster than traditional Python lists, making them ideal for data science. There are two types of NumPy arrays: vectors, or one-dimensional arrays, which are flat, and matrices, or two-dimensional arrays, which have rows and columns. You'll see I've put here, vectors are just like a list, although they can have additional mathematic capabilities. Matrices are like tables, with rows and columns. You can access the row and columns of the matrix using indexing and slicing. We'll get into all of this later. As a side note, let's take a look at what is the difference between a matrix and a table. They look pretty similar, right, with rows and columns, this being a matrix and this being a table. A matrix is used for mathematical operations, whereas a table is a collation of data which is organised again into rows and columns, instead just for organising and analysing your data. Pandas, and we'll come back to this later, but pandas build on NumPy. It's an open source library built on top of NumPy, allowing for fast analysis and data cleaning, with built-in visualization features which won't be covered today. Pandas are used for data manipulation and analysis, mainly again in a tabular format and in series. It provides tools for data cleaning, filtering, grouping, merging, and visualization. Firstly, NumPy, numerical Python. How do you install the library? Well, if you're using the Anaconda distribution of Python, which I recommend for data science, or here we're using the online and collaborative Google Colab environment, you go to the CMD or your Mac terminal and type conda install NumPy. If you're using a different IDE and you don't have the Anaconda distribution, you can simply use pip install NumPy. Then you would follow the pip install NumPy with import NumPy as NP. So let's get started. First, we'll run through a series of example use cases. Let's say you want to create an array. To create a NumPy array, and don't worry too much about the code here, you can pass a list into an array. You can also access elements of that array through indexing and slicing. You can use arithmetic operations, addition, subtraction, and so on. There's also array functions allowed. You always start with running this, pip install NumPy. You only need to do this once in your IDE. However, import NumPy as NP will need to be done every time you open the Python environment. Let's run that. You can see by the tick, we're all good. It'll also tell you how long it took. Now let's make a list. My list equals, in square brackets, 1, 2, 3. And all of this basics was covered previously in our last Python episode. Now let's cast this list to an array with np.array. Remember, we've stored NumPy as np. np.array mylist, which is the variable for our list. Now we could even assign this NumPy array its own variable. So array equals the NumPy array of my list. This will return a one-dimensional array. So we've done this. Let's return it by typing array. And here you go. You'll note it's one-dimensional. But what if we wanted a two-dimensional array, a matrix? Then we can cast a list of lists. So let's take a look at this output before we cast it to an array, and then look at what the difference is. You'll see, just in a series like this, we have 1, 2, 3, 4, 5, 6 in two lists. But let's cast it to an array now. We'll do this via np.array. Remember, capitalization matters. We'll even assign it a variable. Then when we call the variable, we'll get this. As you can see, a matrix with rows and columns. Now why do this? Why cast a list to an array? Well, NumPy arrays are faster than usual Python lists. They use less memory, they can perform operations, and they can be easily sliced and indexed. However, this is not typically what you'd use NumPy for. Instead, you'd use NumPy's internal generation method to create arrays faster. Let's take a look at some of these. For example, np.arange 0, 10 will give you a range of numbers from 0 to 10. Now remember, the first number is inclusive, meaning we will get 0, whereas the second is exclusive, so it will only go from 0 to 9. We'll see that here. We can also add into this a step size. We want it to go up in 2s. So it's a very fast and easy way to get this list rather than typing each value out. But what if we wanted an array of all zeros? Well, very simply, np.zeros. We'll take 7 of them. We could also pass through an array of tuples. This will give us rows and columns to get a matrix. Alright, fine. What about an array of 1s? 7 of them. Again, possible. And an array of 1s and tuples? Yep, a 2-dimensional matrix of 1s. Next, we'll go to random numbers. np.random.rand5. Let's run this and see what it does. It'll give us a uniformly distributed 1-dimensional array of random numbers. You'll see these are floats rather than integers. What if we wanted this random array but in a matrix, 5 by 5? Well, very simply, comma 5 would do this. And here you go. You can see just how quick NumPy is for Python. What if I wanted a random integer of low to high number rather than floats? Well, you rand int. Let's do 1 to 100. Try specifying a number of random integers, say 20. Let's take 20 of these random integers. Simple as that. Now we'll explore some useful attributes and methods of an array. Reshape. With NumPy arrays, as you start to explore this, you'll find that you need to change the shape. For example, you may want to change the shape of an array to make it easier to visually process the data. You can do this with the reshape function. This function takes the original array and puts it into a new shape. For example, if you have a 1-dimensional array with 10 elements, you can reshape it into a 2-dimensional array with 5 rows and 2 columns, like this. Let's take a look at what it's doing here. We have a NumPy array of 10 elements stored in the variable A. Then under the variable B, we take this array and reshape it in 5 by 2. We then print it, and we have a 5 by 2 NumPy matrix. Other useful operations are min, max, and index. Let's start by creating an array. Array equals np.arange 0 to 11. We can look at the minimum of this array and the maximum. Equally, we can pick out elements via indexing. Remember that it always starts with 0. What if we wanted something at the 8th index? We'd get 8. And what if we just wanted to print the array? There you go. Slice notation could be used too. Easy. We can look at 1 to 5. Again, you could say everything up to the 6th index, like this. Broadcasting. This will broadcast the values of 100 to the first 5 digits. So we're taking a look at the values 0 to 5 in the index and then making these equal to 100. Let's try it. You'll see now it's 100, 100, 100, 100, 100, and then up to 10. Let's get another array of 0 to 10 with array equals np.arange 0 to 11. Then we can use slice notation to make all these values 100. First of all, let's start with this. Let's just print the array. Here you go. Now let's use slice notation and reprint the array. You see all these values become 100. Next, we'll take a look, a little bit more complex, at indexing a 2D array, a matrix. Let's create this matrix with arrays stored within arrays, or also known as n-dimensional arrays. First of all, before anything else, let's print it, or return it to see the output. Here you go. Say we want to look at row 0, column 0. This should give us 5. What if we want the entire first row? We just put 1, 0. Now it is recommended, instead of doing this within 2 separate brackets, to use a comma, 2, 1. This will give you 40. Row 2, the first column. What about if you wanted a chunk of an array? You can use a colon as slice notation for entire selections rather than single elements. So this is everything up to row 2 and everything from column 1 onwards. And as you can see, we have an entire chunk. Now we're almost at the end of NumPy arrays. Now let's create an array. np.range 1 to 11. Let's output it. Here you go. This is 1 through 10. Remember, the first value being inclusive and the second not. Let's take this array and combine it with comparison operators to get a full Boolean array. So array greater than 5. This will tell you where it is greater than 5 or isn't via true and false. In fact, we can even save this under its own variable we'll call bool array is greater than 5 and then call it to get the Boolean array. You can also use this for conditional selection. This will only give you the values where it's true. So let's see here, and then let's call it. These are the values where it's greater than 5. You can see here, it's calling this array with this variable, being the original array where it's greater than 5. However, this is just to outline how it's done. Commonly, it would be done in one step, just array greater than 5. A lot more simple. Let's run some operations. You'll see here I have an array from 1 through 10 via np.arrange 0 to 11. Now, what if I wanted to add the array to itself? There you go. You see each number was added to itself. You could also do array minus array or array times array. Let's try this. Equally, we can do scalar operations, adding to every element in the array. So let's take a look at this again. And then let's add 100 to each of the elements in the array. Finally, universal array functions. These are essentially mathematical operations you can use to broadcast the entire array. You can find the square root, the minimum, the maximum, and so on. Now, and finally, to the next section, pandas. We've covered what pandas are, an open source library on top of NumPy, allowing for fast analysis and data cleaning, with some built-in visualization features which won't be covered today, but we will look at later. Now here's some of the things it allows you to do. Filter, sort, and aggregate data. You can input data from a variety of sources. You can join and merge that data, create new calculated columns, and reshape the data. Now how do you install it? First, as always, we'll pip install pandas and import NumPy from earlier, and then pandas as PD. Then we'll get started with a series which is similar to a NumPy array, but with an axis label, meaning it could be indexed by that label. You'll see here I've already run it, but I'll do it again just to show that it works. It'll take a second. There you go. It only took 4 seconds, but it may take longer if it's your first time doing this. Let's start with 4 objects to create a series from. 2 lists, a NumPy array, and a dictionary. We'll run this. You see the list being within square brackets. We'll then make this into a NumPy array. You're seeing the array being my data here. We are casting this array into a NumPy array. Then we'll create a dictionary with the key A relating to the integer 10, B 20, and C to 30. Now from this, let's create some series. PD, remember we imported panda as PD, dot series, capitalization matters. Data equals my data. Let's run that. You can see it has an index 0, 1, and 2, and then the actual data, which was the my data. The key to a pandas series is that you can specify what you actually want the index to be. So let's do the pd.series data is my data, but then let's make the index labels, which we assigned earlier. Let's run that. And you can see now we still have 10, 20, 30, but the index is A, B, C. Let's now cover some more ways to make a series. You can use pd.series and then just pass in a NumPy array. You can see we have the array from earlier, ARR, which was the NumPy array. Pass this to a Python series. Again, you could also pass in the labels, if you so chose to. Finally, you could pass through a dictionary, pd.series and then the variable d, which was associated to the dictionary from earlier. Now we've learned how to create a series, let's look into indexing these series. We'll start with creating two series. Series 1 being pandas.series, capitalization matters, 1, 2, 3, 4, and apples, dogs, car, and pears. This is similar to a dictionary, in that one will be associated to the other. And another similar series, but the only difference being car and bike don't link up. If we want to look at the key apples and output its associated value, we would type in series 1 apples, and this should give us 1 because it's the first in the series. Also, if we did series 1 with the operator plus series 2, this will try to match up the operations based on the index. Where it cannot find a match, such as car and bike, it will give you a null value. Apple and apple, so it added 1 and 1 to get 2. Bike and car don't match, but dog does, and so does pear, adding 4 and 4 to get 8. Now onto data frames, which can be seen as the main tool of pandas by some. So, from numpy.random, let's import randn. This will give us a random array. Let's explore dataframe commands. So the dataframe will assign it the variable df. We'll create via pd.dataframe randn, which we imported earlier, 5, 4, and a through e, and w through z. Now what is this? It looks quite complicated and messy, but here's just a list of columns, w through z, and rows, a through e. You can see this becomes a data frame, which is just a bunch of series which share an index. Let's get rid of this and then run that. If we then output it via df, you'll see there's 1, 2, 3, 4, and 1, 2, 3, 4, 5. 5 rows, 4 columns. Again, the first set of numbers being how many rows and columns you want, which are associated with the next set. This being the name of the rows, 5 of them. And this being the title of the columns, 4 of them. And you can see the actual numbers, we've just put random. There's our very first data frame. But don't worry too much about creating it because we're looking at indexing it. Let's say we want the W column. Well, here you go. What if you wanted multiple columns? The data frame within 2 square brackets, W and Z, giving W and Z. And there we have our data frame. What if we wanted to add a column to it? Well, let's add a new column called new, which is just going to be the data frame column W, add the data frame column Y. Let's run that. You'll see now if we output the data frame, we'll have a new column called new, which is the sum of Y and W. But what about removing columns? Well, for that, very simply, and similar to SQL, it's .drop. This will output the data frame without the new column. But let's recall that data frame, and you'll note it'll still have new. Let's take a look. df. Still got new. So why has it done that? Well, that's only temporarily removed it for this specific output, but if we want to permanently get rid of it, we have to do it in place. Same as before, we're specifying the axis, 1, being that we want columns, because by default it's rows, zeros. In place, true. There we go. And now if we run it later, it will truly drop. We can also use df.drop to remove rows, but for this we just use axis equals 0. And again, remember this is not in place, so it will remain. You can see we got rid of the E row. Next, let's explore how to select rows. Well, we use the .loc method. So df.loc, the row A. What if we wanted to select a subset of rows and columns? Well, you pass in the row B and then the column Y. You can also pass in a list. Let's use a comparison operator against the data frame to see where it's greater than 0. We just do it like this. Data frame where the data frame is greater than 0. And here you go. You can also pass through specific rows or columns, which is likely what you'd use to filter out the row based on the column values. Just like this. But what if you had multiple conditions? Well, you can use the AND operator. So w greater than 0 and y greater than 1. Or you could use the OR operator. Let's create a new index. Here we have some states. Let's do that first. And then let's set this as a column within the data frame. So data frame will have a new column called states, and this will be equal to new index. Let's call the data frame and explain that. You'll see we now have a new column called states, which is now equal to new index, these values. We're getting close to the end now. Let's look at missing data. We're done with data frames, no more data frames for today. When you use Panda to read data, it will automatically fill in with null values, or NaN, as you saw previously. Let's explore how to drop or fill these values. First of all, we're going to create a data frame from a dictionary. This dictionary will have 3 keys, A, B, and C. They will be our columns. And then for each data point, we'll pass in a list of values, 1, 2, and then null, 5, null, and null, C, 1, 2, 3. Let's do that. And then let's turn this into a data frame under the variable df. There you go. But let's say we wanted to drop a value. Well, all the NAs. Let's do df.drop NA. And there you go. No NAs. But what if you want to do this for columns rather than rows? Well, you just make the axis 1. No longer rows, but columns. You can also specify a specific threshold, meaning you'll require a certain number of null values before it gets dropped. Next, onto .fill. Means we'll replace the null values with fill value. But perhaps you actually want to use this to clean your data, and so you'll make the value the column's average, or mean. Here, in column A, we'll fill the null values with the column A's mean. Group by. Group by allows you to group rows based on a column and perform an aggregate function on them. What is an aggregate function? Well, an aggregate function is anything that turns a number of values into just one, such as finding out the minimum, the sum, the max, and so on. So let's say you have the following data frame. You can see here we had an error. That's just because it's all the way to the end and it shouldn't be. I thought it was part of the same thing. Let's take a look at this via df. Don't worry too much about creating this data frame. I'm more concerned about grouping. So we can group by company. We'll call the variable by company, and then within a data frame we'll group by company. Once you've done this, you can then call an aggregate function on it, such as the mean. So by comp mean. And there you go, it's grouped company together and given you the mean for each company. And this is where you really start to see how valuable pandas can be within Python for your data science. We can also use .describe. Now this is brilliant. Let's group it by company and then .describe. This will give you an overview of all the values for the company, such as the mean, the standard deviation, the count, the min, the max, and so on. You could even use .transpose on this to then flip it. And there you go. You can see that it flipped it. Whereas if I don't transpose it, it'll come out the other way around. Let's create a data frame consisting of 3 columns and an index of 0 to 3. Let's do this and then call it. You can also use .head to return the first 5 rows by default, or specify specifically how many you'd like to return. Now let's take a look at this. We've got col1, col2, and col3, and within those, these are the data values. df col2.unique will return a NumPy array of all the unique values in the second column. But let's say we want the number of values itself. We start with len, the very same thing but with len at the start. And it tell you 1, 2, 3, there are 3. Equally, pandas has its own unique method for this, and unique. And unique method gives 3. You can see there are many different ways to do this. Next, we can do value counts. This gives a table of unique values and how many times they come up. Now we know we can use methods that are built in like sum, but what if we wanted to apply our own custom function? Pandas can do this also. So let's say you have a function that multiplies an input by 2. You define the function and call it times 2. And then you could apply this and broadcast it across the elements within a column. So within column 1, let's apply times 2, x being substituted for the elements within your column. Let's run that. There you go. You can also sort the values via sort values. And remember, I copy and paste this in from a Word doc, so I didn't actually get the correct quotation marks, and that will cause a problem. There you go. I want to note that with pandas, you can merge, join, or concatenate data frames and series, that these are different things, but I'm not going to go over them today. What I do recommend is that you spend time looking into each of these and how they differ. In some ways, it's similar to SQL join, so if you have experience with that, you will have an advantage. Now, this is just the Pandas PyData website. Finally, data inputs and outputs. You can work with a variety of data sources, including CSV and Excel files, HTML and SQL, and to work with these, you install each of these respectively. And then very simply, just pd.read, CSV or Excel, and then the name of the file. You can even write to the file, but to do this, you save it as a data frame. We'll give it the variable df. And that is Python summarized for pandas and NumPy very quickly. Now, there's so much to explore with this, and it's very complex. I'd recommend having a play and seeing how it works for yourself. All the best.